Okay, what we're going to do now is come up with a test for divergence. So let's motivate this with an example. Look at this sum. Okay, let's write down the first few terms. This is going to be 1/2 minus 2/3 plus 3/4 minus 4/5. Okay, so does this converge? Does it diverge? It's hard to tell. So what we would like is a test that would tell us whether or not the sum diverges. So here's that test. Okay, so what we're going to do to prove this theorem, let's suppose that this sum converges. Okay, let's suppose that it converges and we want to show that the limit as n goes to infinity of an is equal to 0. That way, when we're taking the limit and we get something that's not 0, we'll know that it cannot converge. In other words, it diverges. Okay. So if it converges, I can say S is equal to the limit as n goes to infinity of Sn is equal to where Sn is equal to the nth partial sum. Right? So this limit exists. Okay. So next, look at what Sn plus 1 is. This is the sum from 1 up to n plus 1 of an. So if we write down the first few terms, this is a1 up to an, and this is a1 all the way up to a n plus 1. So if I subtract those two things, the only thing I'll have left is an plus 1. Okay. Now, let's take n to infinity. Okay, this guy, as n goes to infinity, goes to s. And this guy also goes to S. Okay. So what I get is that limit as n goes to infinity of this term, an is 0, which is what I wanted to show. So I'm done. Let's do an example. Okay, how would you prove this? Well, all I need to do is apply this test. Look at the limit of what I'm summing. What I'm summing is n over 4n plus 1. This is 1/4 as n goes to infinity because these are both polynomials and it's going to go to the quotient of the lead coefficients. So this is not 0. So the sum diverges. Okay, a word of caution. The converse does not hold. In other words, if the limit as n goes to infinity of an is 0, this sum So the test doesn't tell me if a sum converges or not. Okay, so if this is not 0, I can conclude that it diverges. But if I get that it is 0, it doesn't tell me that it converges. So for example, let's look at the sum of 1 over the square root of n. So certainly this sequence goes to 0, but the sum diverges. Why? Let's try to see why the sum diverges. Well, let's write down the first partial sum. This is 1 plus 1 over root 2 plus 1 over root 3 all the way up to 1 over root n. This is strictly bigger than 1 over root n plus 1 over root n all the way up to 1 over root n. Where here there are n terms. So think of n as like 100. Certainly 100 is bigger than 2 or 3. So if I divide by a bigger number, it's smaller. So this sum is smaller than this sum. Okay, so if there's n terms here, this is n times 1 over root n, which is just root n. So Sn is bigger than root n. Now we can take a limit. This sum here is the limit of the partial sums. So it's got to be the limit of Sn. This is bigger than the limit as n goes to infinity of root n, which is infinity. So the sum diverges to infinity. So to summarize, my test says that if what I'm adding here, the limit does not go to 0, then it diverges. So in this case, we get something non-zero, so it diverged. But if the limit is equal to 0, the test doesn't tell me anything at all.